we are going to presenting about the data warehouse final projects which we done about the special design technique for data engineering. So here is our team member, รัฐพงษ์ ประสิน นรพัฒน์ and ธัญธร The objective of this project is to design and implement a data warehouse based on the online transaction database to create a visualization and also find the business insight. So the technologies and tools that we use for this implementation is Microsoft SQL Server for the query and also creating some DDL. And the second one is the MUS RDS, and the third is the Glue for ETL. So here is the database that we used. It is a sample database from the Microsoft, which is called the AdventureWorks. It is a it's a simulate a fictional company that sell a bikes and the cycling accessory, and also it have the online transactional data set. So it's, as you can see, it has many schema that we can use. And yeah, we need to have some data preparation and data cleansing for the purpose to use like creating our own models and our own visualization. The first process that we're going to use is the sale order process or activities. We want to analyze the sale order, and the second one is the step two is grain. For the grain, is have to level the order level and product level. We choose for the first one, which is the order level, so it doesn't contain any information about the products. So here is the dimension that we're going to use for our model. And yeah, here is all of the measure and it where it's come from. Another process that we're going to analyze is the purchasing products. For this one, we have also have two level of grain, but this one we choose for the products level because we want to analyze some products atomic level, which contain the product theme here. And yeah, here is all of the dimension, and here is all of the measure that we're going to use for our analyze. And yeah, this is all the source that we use. And yeah, all of this will be the base for the dimension. All right.
So after we use the Adventure data work, but we also do the data preparation and data cleansing to select the relevant data for our project. So there are 4 steps in total. So the first one in the sales customer role. Firstly, we eliminate the role that has null value in person ID or store ID. So we only keep the one that has value in both because we want to analyze both the customer information and also the store information. So that's reduce a lot number of person from almost 20,000 to only 600. So that's very good for our storage. For the second step in the person dimension, it contains all the information for all the person. But since we only want to analyze the employee and the customer person, we only extract the person that person that in the employee dimension and customer dimension. So that's also reduce a lot of data. And for the sale person, we also eliminate the sale employee who has null value in sale quota.
For this one, since some of the sources they have some like we want to analyze in the level of order, right? But you can see that this one, each order can have multiple details. So we need to perform some aggregation in order for us to use as an data inside the fact table. So after cleansing everything from the source, we load it back to our source database that's stored in the RDS. But at first we try with the S3, but it's consume a lot of time and resources. So we find a new way for load the data, which just click on the database and import data. And you need to select for like the fat file and also need to configuration for the SQL server as well. All right. So here is all detail about the SCD types of all of the dimension that we're going to use. For the date dim, we're going to use the type 0 because it's predefined and it will not change. Second one, second one is customer is type 2 because we want to track change. And customer address dim, this is the out trigger from the customer dim. So it store the information that not change a lot. And also we want to not consume a lot of space if we want to like make some change on the customer dim. And address, we want to track change and yeah, collect all important data. The employee dim, we use the SCD7 for this because we want because the cell employee we want to analyze the cell. So usually there is the employee dim doesn't contain only the cell employee, but they contain a lot. And yeah, we want to collect only the cell employee and use only in extract only the cell employee. And the fifth one is the currency rate. So it store the information about the US conversion to other currency. So we doesn't want to track change because it's going to be a lot of data. Credit card is store the detail of each card that the customer use. Shipment is contain the detail which company that the customer used uh to send the order. The store going to uh store information about the branch or the location of this branch. The products going to collect all the products detail and vendor. Vendor will collect all the vendor details and we just need a lot of change in there. And yeah, here is the schema that we plan. And this is the ER diagram from the Power BI. So the conform but matrix. So for the sale order fact, we use 9 of them. And for the purchase products, we use 5 of them.
So after understanding the process of designing, now we're going to perform the ETL task on AWS Glue. So first we load the data into a different dimension, but since we also predefine the SCD for each dimension, so for the customer dim here, we use the SCD tool. And as you can see in the slide, you can see that at first for the customer dim, we join the customer database with the person database, and then we left join using the key from customer. And then we also join with the customer dimension in the data warehouse to update it if there is any new data coming in. And then after that, we derive a column, which is we create a is new column to see and to use as a condition to see if the data coming in is new or is already exists in the data warehouse. If it's new, then it will go to the left side, and then we will add an is active is active column to that new data and change it to is active, and then um, add a new row. But if the data is not new, it will go to the right side, and then we would check if the data is changed from the past. And if it is changed, we only filter the change data. We would update the is active status of the old row, and we will also append the new row with the positive active status. So for the employee dim and product dim, we also use SCD2 as well. So for employee, we combine employee and person. For product, we just reload the product directly. For store dim, we also use SCD2. We combine the store and customer database in. And for the cell employee, it's the mini dimension, it's the extra dimension of the employee. So we use SCD1, and it is a little bit different from SCD2 since we don't need to add a new row, but we only filter if the data is changed or is new, and then we if it is new or is changed, then we rewrite the row. So these are some more dimension of SCD1. So customer address, we combine the customer address with the old data with the data warehouse. And a credit card and currency rate, we also use SCD1. And also shipment and vendor, since there's not going to be a lot of change that we want to try. And lastly, after we load all the dimension into data warehouse, we then perform the loading into the fact table. So first, sale order fact, as Bunch said, and we can see in the bus metric, we use all the dimension that it's written down here. So we join all the dimension. And here is for purchasing facts. We also join the dimension. And we also rename the column to prevent the same column name. And after creating all the job, we put all the pieces together in the workflow or the orchestration. So as you can see that first we start the node, and then we load all the data into dimension. And then after all the data in the dimension is loaded, so it passed the condition all, it would load the data from the dimension to the fact table, which is sale order fact and purchasing fact. Here is the proof that we have run it and complete the job.
That is all.
Thank you.
Thank you.